Hello, ladies and gentlemen. Welcome to the second part of the lab, part 2, where our goal here is to find the density of 6 different liquids. To get started on that, I want to make sure that I show you the chart that I'm going to be using is the chart that you see right there. The liquid A mass of graduated cylinder and fluid, and this will actually be over in the it'll be in the video for you. But just want to give you a little heads up that I'm going to be using that chart there and basically filling in steps 1, 3, 5A, 2, 4, 5B, and 6, and it'll make a little more sense once I get started on filling in the chart. But what I'm going to do is I'm going to have myself a little piece of paper like this. I recommend you doing something similar. I've got liquid A listed at the top, and then I'm going to go and do the same numbering just as you see in that little image above this video. 1, 3, 5A, 2, 4, and 5B, and followed up with 6 at the end. And you'll notice there that 6 is actually 5A divided by 5B, and that'll go over there. Okay, so let's get started with liquid A. I have my recording here. And liquid A is a little bit funky. This is liquid A. And we're going to start off with following, again, like I said, following the chart. And the chart has us looking at the mass of the graduated cylinder and fluid. So I'm just going to pour a little bit of this fluid into this graduated cylinder here. Now, it doesn't matter how much, just as long as I pour some to get a first reading, because that's the important part. All right, give that a chance to kind of tap down. I'm also going to go and put on the scale here, and I'll be sure to bring the camera over so you can see the scale in a moment here. All right. So I'm seeing 48.7 is my initial mass here, and as I'm looking at this right here, I'm trying to go and get my graduated cylinder in focus, and I'm trying to find the bottom of the meniscus. The bottom of the meniscus appears to be roughly, not the bottom of the meniscus, wow, look at that. So the bottom of the meniscus is at 11, even though you can see the lines on the side there are going a little bit higher than the 11, they're closer to 12. The meniscus itself, the bottom of the meniscus, is at 11. Just to confirm, we're going to hold this up here. Yep. So the bottom of the meniscus is at 11. So let me go and get some of this data recorded here. So I apologize. This will be my first time doing this, and I have to kind of finesse this here. So number 1, mass of the graduated cylinder was 48.7. And that's in grams. And then my volume initially was 11, so that's going to go for my number 2. The volume of the fluid initially is 11 milliliters. Now, I'm going to go and add some more of this green fluid A, and again, it doesn't really matter how much I add. Density is one of those cool properties. It's a characteristic property, which also means that it is consistent and will stay the same regardless of how much of this liquid we actually measure out. All right. So we got a new reading here. I'm going to put this on the scale, make sure my scale is all zeroed out. And for those who want to be able to see what the scale says 80.3. So that's going to be my number 3 is 80.3 grams. And my new volume reading, the meniscus is just under 41, 42, 43. So it's just under 43. So I'm going to say, well, it's actually pretty spot on with that. So let's say 43. Okay, so volume is 43 mLs. All right, so there is the data from liquid A. You've got 48.7 grams. After I added the liquid, it went up to 80.3 grams. My initial volume for number 2 here was 11 milliliters, and then number 4 went up to 43 milliliters. And with that information, you'll be able to calculate 5A, 5B, and 6, which is the density of liquid A.